Okay, this video is about the change of base formula. If you're working with logarithms, it's probably one of the most important things. There are several important things, but if you actually want to calculate a log on most calculators, you're going to need to know the change of base formula. And quick example, grab this calculator. We're going to zoom in on it real quick. Maybe. There we go. And stop everything from moving around. And you will notice that this thing has a natural log button and it's got a common log button, the log. But how do you do a log in a different base? What do you, if you want to do a log base 3 or a log base 13? Well, the change of base formula is the thing that comes to your rescue. So we're going to go ahead and zoom back out. And I'm going to show you how to do the change of base formula. So let's imagine that we've got some kind of exponential problem. Let's say we've got, let's just take 5. We want to raise it to a power and we want to get 42. Now there's some number x that we can raise 5 to and get 42. The trouble is, how do we find that quickly without just guessing and checking for a long time? I mean, we know that 5 squared is 25, so x has to be larger than 2. And 5 to the third power is 125. That's way too big. So it's probably going to be a little closer to 2 than it is to 3. We could make some guesses, but it might take us a long time to find a really exact answer. So what we're going to do is we're going to first convert this to its logarithmic form. And when we do that, we're going to get a log base 5. We're going to say log base 5 of 42 is equal to the number that we're looking for. Okay, now that's all well and good, but once again, our calculator, remember, doesn't do log base 5. We can do log base e, and we can do log base 10. So how do you do a log base 5? Well, there's something called the change of base formula. And it lets you convert any log problem that looks like this using any base you want. So for instance, I can take my log base 5 of 42 and I can rewrite that using natural logs just by taking 42, which is the result you're looking for, and taking, let's go with natural log, and divide it by the natural log of the base. Now there's nothing special about using the natural log. I chose it because that happens to be the button that's easiest to get to on my calculator. Okay, if you've got a log button, a common log button, then maybe you want to just convert it to a common log and you can do the same thing. It doesn't matter what base you use. In fact, maybe you inherited some really strange calculator from some space alien and they do everything in log base 7. So they have a special calculator button that does log base 7. Well, no problem. You could use their calculator and do log base 7 of 42 divided by log base 7 of 5. Now, in our world, if you could do a log base 7, you could probably do a log base 5 and you wouldn't need this conversion. But on most calculators, you're given choices between doing a common log and a natural log. And the reason that they limit you to those choices is they don't need to make the calculator any more complicated than that. Because you've got this change of base formula, and if you're messing around with logs, well, you probably know the change of base formula and you know you can get around this. So let's go ahead and calculate this. This calculator works kind of halfway between reverse Polish notation and algebraic notation. So in this calculator we actually enter the 42, then hit the natural log. Then I'm going to hit the divided by 5 natural log. And then I got to hit the equals. And it tells me that 2.32 Should be a pretty good answer. Now that's probably approximate. We can check it by simply taking 5, raise it to the 2.3223 in the calculator. And I'm sure this calculator has a button that will do that. So we're going to hit 5 and we're going to raise it to the 2.3223, hit equals, and this calculator comes up with 41.9970. Not super close, but you got the idea. It managed to do the heavy calculation for you. And that's the change of base formula.